Hello and welcome. What do you call a belt with a watch attached to it? A waste of time. Special thanks to business calculus student Edward for that one. Now, what isn't a waste of time is learning about power series. Let's get started. A power series about x equals 0 is a series of the form c sub n times x to the n, where n goes from 0 to infinity. So we have this summation, we have this series, but the terms of the series are written as c sub n times x to the n. So if you expanded it out, you get c sub 0 plus c sub 1 times x plus c sub 2 times x squared plus all the way to c sub n times x to the n and beyond. Notice that this is a function of x. This is a function of x. Every value of x that you input into this power series is going to create a specific power series, like a regular series that we've seen before, that will either converge or diverge. So you can think if you plug in a particular value of x, like let's say 3, and you get that the series converges. That was a bad example because that usually it wouldn't converge with 3, but it could possibly. Let's say you plug in a half and the series converges. Then that would mean that when you input a half, the output is whatever that series converges to. Let's say you plug in 5 and the series diverges. Well, that would mean that the function, at least written in this power series form, is not defined at x equals 5. The series would diverge. So the main thing is that the power series about x equals 0 here is going to be some kind of function of x. Now you can also write the power series with a different center. So a power series about x equals a, where a is any number, is a series of the form n goes from 0 to infinity of c sub n times x minus a to the nth. And I forgot where my clipboard is. Where did that thing go? Huh. Oh, there it is. Okay. Sorry about that. All right. So what this looks like is c sub 0 plus c sub 1 times x minus a plus c sub 2 times x minus a squared, and so on. So here it's a slightly different center. We'll see why we're using the term center, but a here it was representing what's called the center of the power series. It's going to represent the center of convergence of the values of x for which the series converges. And these c sub 0, c sub 1, c sub 2, and so on, these are just constants for the power series. And they could be a function of n, but at the end of the day, they're constants. And then the x part is the variable part. Now, why are power series so cool? Well, it turns out that power series can give us alternate forms of our elementary functions, like sine x, ln x, e to the x, and so on. Also, power series can allow us to create new functions that we previously couldn't write using these elementary functions. Power series are also useful for approximating functions. When you write out the power series expansion for a function, you can stop at a certain point, and that'll give you an approximating polynomial, a polynomial that will approximate your function that you're interested in. Power series will also help us integrate functions that previously we couldn't integrate, and solve differential equations that previously we couldn't solve. So power series are really cool, and over the next few sections you're going to learn more about exactly why they're so cool and how they're helpful. For this section though, we're just going to be interested in knowing, does a power series converge or diverge, and specifically for what values of x does it converge or diverge. Let's look at example 1. Here we have the series n going from 0 to infinity of x to the n. This is a power series because it's of the form c sub n times x to the n. And if you write out the terms of the power series, you'll get 1 plus x squared plus x cubed, and so on. And we're asked, for what values of x does this converge or diverge? Well, you might recognize this. This looks very familiar. This series, x to the n, is a geometric series. It's a geometric series because it looks like every single time you look at the next term, you're always multiplying by x. Or you could recognize it because the series is of the form AR to the n, where instead of an r here, we just have x. That's like, x is like our common ratio. So we can write this is like a geometric series with a equals 1, because the first term of the series is 1. That's our a value. And the common ratio, r, is x. Now we know exactly where geometric series converge and where they diverge. So this is going to converge. In fact, we can even say what it converges to. It's going to converge to 1 over 1 minus x when x is between negative 1 and 1. And remember, our shorthand for that is absolute value of x is less than 1. That means x is between negative 1 and 1. And it's going to diverge otherwise. Okay. So that's where it converges and diverges. We're going to make a little side note and notice that when the series x to the n converges, when that power series converges, it converges to 1 over 1 minus x. We're going to store that away in our brains for later. 1 over 1 minus x is the same thing as this power series, x to the n, when it converges. So that would be for the x values between negative 1 and 1. All right, well, that's good for this video. I think we'll head to example 2, 3, and 4 in the next one. Thanks for watching. I'll see you in the next video.